Tonight's homework is to add examples 2 and 3 into your Spiral notebooks and actually fill in the information. I've already did the PDF of the slides prior to this, um, but I'm just going to do this example with you. And so if you just get this information in, this is what I'm going to be checking for. So what we're going to do is we're going to provide the statements that would justify each step. And we will do some more of these in class on Monday. So the first thing I think we already know is right here. They tell me angle 2 is congruent to angle 4. And it even says right there that that is our given. Okay, so we write given for the reason for that step. And then I'm going to get information from the diagram that we have up here to justify the statement and the reason for it. So I'm hoping you can see physically that angle 1 and angle 2 form a linear pair. Well, that's just, and I'm going to abbreviate some things here, definition of linear pair. Okay. And if you want to do LP, I'm okay with that because I'm going to probably start doing that. LP for linear pair. Well, if it's a linear pair, then they're supplementary. So angle 1 and angle 2 are supplementary. So that was our linear pair. This is what we had on our vocab earlier on the previous page. Linear pair theorem. Okay, linear pair theorem states that they are going to be supplementary. Well, now I'm going to state that angle 1 and angle 4 are supplementary. Now, basically, how did I get that angle 1 and 4 is supplementary? Well, since I'm going to go back to step 1, since I said 2 is congruent to 4, okay, so instead of having 2 here, I'm now substituting it with 4. So here is where I'm using substitution. This is just plugging in another angle for its value or for its equivalency. This is different than transitive property, and I will talk about that. I know we did some things to show how we can use transitive property when dealing with substitution. So this was substitution. And then we have 3 and 4 are linear pair. Well, I can see that in the diagram. And so that is also going to be our definition of a linear pair. Which means that 3 and 4 are supplementary. So that's our linear pair. I need to probably scroll this up. Sorry. That is our linear pair theorem. What we did just a while ago. Now, what they're doing next is we're going to see if we can recognize our new theorems that we added in our table previously. Because I want to focus on line 4, okay, line 4 and line 6, okay. So line 4 says angle 1 and angle 4 are supplementary. Now this is angle 3 and angle 4 are supplementary. What I was hoping that you saw was they're both supplementary. They're both a supplement to angle 4. So if they're supplementary to the same angle, then we can state that 1 and 3 are congruent by our congruent, I'm going to use some symbols, congruent supplementary theorem. Okay, our congruent supplementary theorem stated that if two angles are supplementary to the same angle, then those two angles are congruent. Okay, if two angles are supplementary to the same angle, then they are congruent. And so then this last little step here, this is what we're talking about, vice versa. If one is congruent to angle 3, then the measure of 1 is equal to the measure of angle 3. That is just pretty much what it means, our definition of congruency. So if it's congruent, it's equal. If it's equal, it's congruent. Okay, so that takes care of example 2. Example 3, oops, I went the wrong way, apologize. Okay, we have another example. If you need to pause, get it down, but I am going to go through this, and that's pretty much going to take care of it being completed for me to check on Monday. So in example 3, again, we're going to start off with our given statement, which is 1 and 2 are complementary, and we're going to use our figure over here to the right, okay, our figure that we have over here to the right, to do some problem solving and justifying our statements. Well, if 1 and 2 are complementary, then a measure of angle 1 plus a measure of angle 2 equals 90. That basically is our definition of complementary angles. Complementary angles are angles that have the sum of 90, right? Well, I can physically see in the diagram that angle 1 and angle 3 are vertical, okay? And if angle 1 and angle 3 are vertical, then I can also state another property or correlation using a theorem. So first of all, since I physically see it, I know they hold true to be vertical. That's our definition of vertical angles. Vertical angles are formed when lines are intersecting and they are opposite each other. Now, angle 1 is congruent to angle 3 because that we get from our vertical angle theorem. Vertical angle theorem. Now, I'm just going to scroll up a little bit. Oops, please, did I mess it up? I think I did. Is that it? That's correct. Sorry about that. Okay, now, the measure of angle 1 equals the measure of angle 3. That's what we did previously. If it's congruent, it's equal. If it's equal, it's congruent. So this is just definition of congruency. And that's what angles, the congruent angles, if we wanted to. But I understand if you say definition of congruency. Now, the measure of angle 3 plus the measure of angle 2 equals 90. Okay, the measure of angle 3 plus the measure of angle 2 equals 90. So I'm going to go back to some statements to make sure we understand how I got this. Excuse me. I'm going to get this like this. All right, so since in statement 2, I had 1 and 2 equal 90, and I know that angle 1 is congruent to angle 3. That's step 4. Now I can say that angle 3, instead of putting measure angle 1 here, I can say angle 3 plus angle 2 is equal to 90. Now, I'm getting this, I'm able to complete the statement again by using substitution, okay? By using substitution. I'm substituting the measure of angle 3 for angle 1 since they're congruent. And then our next step, we're talking about 2 and 4. They get from the diagram, look at 2 and 4. 2 and 4 are also vertical, so that's our definition of vertical angles. So that means 2 and 4 are congruent. That's our vertical angle theorem. Okay. So the measure of angle 2 equals the measure of angle 4. That's our definition of congruency. And now, because I know 2 is equal to 4, okay, now I'm looking back and I'm just going to circle some things. Look what I have here. And look back up to this statement here. I had 3 and 2 equal 90. Now 2 is equal to 4. So now I'm going to say 3. I didn't say 3 equal to 4, but the sum of 2 and 3 equal 90. And I know the measure angle 2 equals 4. But now I can say 3 by substituting in 3 measure angle 3 plus the measure of angle 4 equals 90. So I'm substituting here again. And so if they have a sum of 90, then they are complementary. So we have just proved that they're complementary by the definition of complementary angles. Okay? All right, so these are the 2 examples I need you to add to your spiral notebook. After that page, excuse me, oops, I went the wrong way again. Then we have these 2 pages that we're adding into. And if you want to go ahead and start, you can, because we have a word bank for these proofs. For example, I'm just going to show you real quick. You're going to complete the reasoning by using these chosen reasons over here, these statements that we have here. Well, we always know the first one is given, so that would be C. Okay? And then by stating that this ray, RV, is bisecting the angle SRT, by definition of bisecting, then angle 1 would be congruent to angle 2. So this is A, definition of bisector. And then, because I knew 3 is congruent to 1, and 1 is congruent to 2, okay? Now we have a middleman. It's a little different. It's not substitution. Then I can say 3 is congruent to 2. And so our last property was our transitive property. So basically on here, on this page, we want you to choose a reasoning to justify the statement that's given using the figure that we have up here, okay? So I want on here, I want you to understand, and we had it in the first one, you can have more than one given statement. So that first part, BD is equal to AD, that is a given. And then AD plus DC equals AC, that was also a given. Then you should know, oh, excuse me, what the last statement is going to be, okay? So here you have word bank, and then on the next set of problems, I went the wrong way, I apologize. When we get to 3 to 7, these are your reasonings for all of them. They could repeat, okay? So go ahead, we're going to work on this in class, but just kind of give it a try, all right? And you'll be ready to get ahead on your actual assignment that you're going to get on Monday. That if you don't finish, you'll have to finish for homework. All right, thanks. Have a great weekend. I'll finish grading these tests. I'll be in there, and everyone will get them back on Monday. Bye.